Thank you for joining us for our latest webinar Wednesday, The Machinery of the Mind, presented by Allan Barger. Allan Barger is a research analyst at the Prevention Research Institute, Incorporated, called PRI, and has over 20 years of experience, including work as a rural community alcohol and drug prevention volunteer and as a prevention specialist in urban community mental health centers. He reviews research literature on drugs, particularly marijuana, and the effects of alcohol and drugs on the brain and behavior. He has an MSW from the University of Kentucky and now lives in Palm Springs, California. PRI's signature program is Prime for Life. It's an evidence-based therapeutic education with demonstrated success in significantly altering attitudes, increasing abstinence, and reducing high-risk drinking and drug use in early teen years through adulthood. Okay, Allan, I'll make you the presenter now, and you can take over.
Okay, thanks very much. Well, welcome, and I'm glad to be here this morning. Let me get my screen set up here so that you can see the slideshow.
Yeah, click on that box in the middle of your screen that makes you the presenter.
Okay, I will do that. Okay, hopefully, yeah, I was going to say, hopefully what you're seeing here now is the title page for the presentation, Machinery of the Mind, How High-Risk Choices Redesign the Brain. And so what we're going to be looking at today is just how the use of alcohol and drugs actually alters brain function in a way that sort of characteristically produces the behaviors that we see that are typical with addiction. And so I always like to start with a little fun, and usually when I do this with a live audience or I should say a face-to-face audience, because we're a live audience here, but not face-to-face, what I like to do is play a little game with the audience, which I can't do with you, but I want to describe it because I'm going to actually refer to this a couple of different times. So what I do is I ask people just to take a look at this $20 bill that you'll see here, and then I pull from my shirt pocket an actual $20 bill and tell them that I am about to give it away. So just for the experience, I'd like for you to imagine for a moment that you're sitting in an audience with a presenter, maybe me as a presenter, and I'm saying to you, I am now going to give away this $20 bill. And the way that I'm going to do that is, in a moment, I'm going to ask you to raise your hand, and the first hand that I see go up gets the $20 bill. And this generally creates a little bit of enthusiasm in the audience because I do actually give away this $20 bill. And so I tell the room to get ready. I say, now the hands shoot up, and the first person whose hand I see actually up, I give the $20 bill to. And so that's how I usually start this, because that's going to be an experience that I can come back to talk about some normal brain functions and how those sort of get hijacked into the addictive process. So in exploring what's going on in the brain, there are a few key concepts that I like people to keep in mind. First of all, the brain and mind are reciprocal. And what this means is that they are intertwined, as you see with this, these intertwining arrows here going different directions. The brain, it produces our mind. The mind is psychological, the brain is biological. But the brain produces the mind, but in return, the mind also can alter the actual, not only function, but even physical structure of the brain. For instance, if you think a phone number that you're learning, if you repeat it to yourself a number of times, or you use it a number of times, your brain will actually wire in synapses that will help you to recall that memory more easily over time. So the brain is creating the mind, but the mind, by repetition of knowledge, and this is just one example of how it works, can also rewire the brain. The second concept then is that these brain and mind functions intertwine with one another. And it's getting increasingly difficult to draw the line between biological and psychological. Also, all of us who have more than one child know that children come hardwired with certain personalities. I think of it as sort of hardware that we're born with. I have 4 daughters, and they came with very different personalities. 2 of my daughters are quite outgoing. One of them is more introverted, and so forth. So we come with this sort of hardwiring that are our personalities. But then we also have software, and this is all of the knowledge and information and experiences and conclusions that we have drawn about life as we have grown and lived our lives. So we have hardware and we have software. And another thing to keep in mind is that your brain is really changing all of the time. I was raised in sort of this understanding that, you know, we were born, our brains matured within a few years after we were born, and then we would, we sort of lived with that brain for the rest of our lives. And that's not really true. We now know that during the adolescent years, for example, the brain undergoes a huge transformation. And even after we are adults, we continue to rewire and change our brains. This is known as plasticity or neuroplasticity. And plasticity simply means that the brain is moldable. It's shapeable. And that is true across all of our lives. Another point that I like to make, and again, this is easier when I have an actual face-to-face audience, but another point I like to make is that our brain actually hardwires, our brain actually gives us our sense of reality. What our brain tells us is real to us. So I invite you to take a look at this image that you have here on the screen. And my guess is by now all of you have found the white triangle. And it is not unusual if I ask a group, how many of you can see the difference in the shade of white between the inside of the white triangle and the outside of the white triangle? And I would say probably anywhere from a half to 2/3 of the group say that they can actually see a difference, and I can too. I can see a slight difference in shade between the inside and outside of the white area around this triangle. And here's the really interesting thing, is that there is no difference. This is not actually a white triangle. The white triangle doesn't exist. Our brain tells us there's a white triangle there. What you have on here in actuality are 3 sort of black Pac-Man type figures. I'm telling my age now. And 3 sort of turquoise-colored triangles. But our brain tells us that there is a white triangle in the center of all of that, and our brain is so certain that that white triangle is there that it will actually tell at least some of us that there is a shade of difference between the inside and outside of that white triangle that we're seeing. Now, that is, there is no difference because I created this image by simply placing those 6 objects on a blank white background. And so there's no difference in those shades of white, but I can actually see a difference. And my point in this is that our brain creates our reality. What our brain tells us is real to us. And that persistence of what is real can continue even when I know it's not real. And so the difference in shade continues in my brain, even though cognitively, in my thinking, I know that it doesn't exist. And it's important to keep this in mind, that our brain gives us this sense of reality. Another way of saying this is that our brain is our window on the world. We take in our world through our 5 senses, at least 5 senses. And so what we see the world being is the world to us. But just as I mentioned earlier, that our own thinking can change the function and even the structure of our brain, it is also true that the world is shaping our brains. If I grew up in a family that was neglectful, where I was rarely touched, where I was not stimulated much in my environment as a young child, was not read to, did not have a lot of stimulation, my brain is going to be different than the brain of someone who grew up in a nurturing and educationally rich environment. And so the world is shaping our brain in the same way that our brain takes in the world and makes sense of it. So in this presentation today, we're going to look at 6 brain-mind functions. We're going to look at reward and tolerance, because we develop a tolerance to all reward. We're going to look at memory and learning. We're going to look at what I call salience and sensitization. We're going to look at impulsivity, how impulsive I may be, and the restraint of impulse, because this creates a lot of issues in our lives. We're going to take a look at decision-making. We're going to take a look at stress and relaxation. These 6 things are normal brain functions. And then I also want to take a look at some things that are specific to addiction in particular, which is withdrawal and loss of control. And these are things that we see as important issues in addiction. So I want to sort of build a cycle for what is going on. Probably most of us have heard the term homeostasis. Homeostasis is simply the normal way in which our brain functions. And so our brain actually works when we're awake and functioning out in the world. Our brain is actually working to keep us between 2 extremes of high and low. Our brain does not want us to be too sedated, and our brain does not want us to be too stimulated. So between those 2 extremes, there is this normal sort of homeostatic area, a range, in which we are relatively alert, and that might range from someplace where I'm laid back in a hammock relaxing, maybe staring at the clouds or reading a book or something like that, where I'm in a pretty relaxed state, to where I may be in a pretty focused state, where I'm balancing my checkbook or working on some hobby that I have, where I'm really intently concentrating. So between those ranges, I have this homeostasis. Now, when I take an addictive agent, alcohol or drugs in sufficient quantity, and I administer that to my system, one of the things that happens, of course, is that goes to the brain. And all of us have something that we can think of as sort of a reward threshold. So let's think about reward and tolerance here for a moment. We have this sort of reward threshold, and all of us, let's use humor as an example of reward here for a moment. Let's imagine that someone has told us a joke that we don't find funny at all. We've probably all had that experience. Someone has told us something and we're like, boy, that really was not funny. That didn't do anything for me. That joke did not reach my humor threshold for the reward of humor. It didn't work. Then we've got the things that are mildly amusing. And then we have the things that are really, really hilarious to us. And this can vary from person to person. It can vary culturally. But what we find rewarding, while it can be different, it depends in part on where our own reward threshold is. So the thing that happens when I administer the alcohol or the drug into my system is that while I am buzzed, drunk, or high, the brain's reward threshold is lowered. So what I want you to notice over here is that thing that I might not have thought was terribly funny before, I'm now, pardon me, I might now find that to be at least amusing, maybe even pretty darn funny. And so while I'm under the influence of this substance, things are much more rewarding. Now what that means is that all of the normal pleasures are going to be enhanced. So my friends are going to feel friendlier, humor is going to be funnier, food is going to taste better. If I'm feeling sexually attracted to someone, that person is going to look and seem more sexy to me. Beer goggles are actually true. They really exist. As blood alcohol levels climb, people look more attractive, even if they're total strangers to us. And so all of those pleasures are enhanced. And what this does is that it casts a glow over the whole evening. So the next day, my memory of this event is going to be, wow, that was a great party, that was a great time, I was relaxed, and the food was good, and the people were fun, and all of it just felt really great to me. So all of these normal pleasures are more pleasurable, and what our clients sort of wondered about was, well, what's the problem? I mean, what's wrong with pleasure? And the answer is there's nothing wrong with pleasure per se, but this type of pleasure actually creates a rebound effect. So remember that under the influence, my reward threshold is lowered. But when the alcohol or drugs leave the system, my reward system doesn't just go back to that baseline where I started from. It's actually going to be raised for a period of time. And what this means is that things that I might have found pleasurable or even very pleasurable over here has in fact now lost its ability to reach this temporarily raised reward threshold. Now, I do want to note that early on, this is a temporary thing, but it lasts much longer than the high. So over here, this can last for a few hours, whereas over here, this can last for several days. For instance, they found with the use of ecstasy, when they look at mood, what they find is that people using ecstasy experience greater pleasure over here while they're under the influence, but for 5 to 7 days after using the ecstasy, they will have less reward response. They will have a lower mood and find life less pleasurable. Now, eventually, they will come back out here to the baseline. The difference is that this is early on, but with ongoing use, this reward threshold can become chronically raised, especially as I'm doing this more often or in higher doses. So I want to be clear about the difference between chronic and permanent. An important thing to keep in mind is that eventually, even if I've gotten into a chronic state where my reward threshold is raised and I'm experiencing less pleasure, or it's harder for me to experience pleasure in life, if I were to start abstaining over a period of time, my reward threshold would come back to the baseline. But depending on the drug I'm using, how much I'm using of it, how long I've been doing it, and my own individual biology, it can last for a period of time, and it will vary how long it will come back to that. But while I'm continuing to use, I can get into a state where my reward threshold is chronically raised, which means I experience less pleasure in life. So my brain's reward system rebounds, and that also means I'm going to have a rebound in motivational systems, because we are moved by what rewards us and what fails to reward us in our environment. We tend to return to things that reward us. We're motivated to do that, and if they don't reward us, they lose their motivation to attract us. So what this means is a higher reward threshold means life becomes overall less rewarding. So here we see the society matron saying, Wendell, I'm not content. And she's there with all of the trappings of the good life, but that life is not rewarding to her as she is doing her martinis day after day and pushing her reward threshold upward. And so life can become more blasé. It's easier for me to be bored. I need more stimulation in order to feel good. So I've now got this cycle that is starting to develop. I've got this acute euphoric reward, and I have a memory of that happening. And I remember how fun it was and how good it was, and consequently, I also have this sort of rebound where I don't feel the rest of my life as rewarding. And so I'm now beginning to develop a cycle of wanting to go back to that fun, exciting, rewarding experience that I had there. This is positive reinforcement. It felt good, and I want to do it again. And we really are wired for pleasure. A number of the chemicals in our brains help us to experience excitement, pleasure, stimulation, and also relaxation and letting go of things, which can also be rewarding. So glutamate is our major brain stimulant. GABA is our major brain, you can think of it as sort of a sedative. It slows down and calms down our brain. Serotonin works in a variety of ways in our moods, and enkephalin and endorphins are our opiates that reduce both physical and emotional pain as we may be experiencing it. Now, I have dopamine here with a question mark, because while we've often heard that dopamine is our pleasure chemical, and dopamine certainly is involved in our motivation system, it's less clear whether dopamine is actually inducing pleasure. More likely, the role of dopamine is that it is creating a stimulant response for us to say, pay attention to this event. It is more a motivational response, because we get a dopamine spike not only in times of pleasure, but also in times of stress. And basically what dopamine is saying is, pay attention to this so that you can either get this again or avoid this the next time if it's a stressor. And so it plays that role. So reward is good. It really makes life satisfying. And reward is shaping our behavior every day. So let me use a mundane example of this. If you go to a store and you are browsing a clothing store, and you're browsing around through the clothing there, and you come across a shirt or a blouse, and you're saying to yourself, wow, that looks real, I like this. The colors or whatever are really attractive to me, and then I look at the price and I feel like, wow, that's a real bargain. Then I try on the shirt or the blouse, and I now like how I look in it or how it looks on me. All of those small rewards sort of adding up stimulate me now to purchase that shirt. So reward has now shaped my behavior. But maybe I've worn that shirt for a year and a half, and one day I put it on, and I'll be darned, the darn dryer has shrunk that shirt or that blouse, and now the buttons are bulging just a little bit, and I put it on and I go, oh my gosh, I look horrible in this. Now, my lack of reward response to that is that I will now hang that shirt in the back of the closet, or I may even get rid of it. I may give it to Goodwill or somebody like that to recycle it. So the reward or my lack of reward is shaping my behavior in small ways every day, all day. And we oftentimes don't think about how important our reward response is in shaping our behavior. But if our job gets too unrewarding, we start job hunting. If a relationship gets too unrewarding, we start thinking about how we can get out of that relationship. So, and that's just part of our homeostatic norm. There's nothing terribly unusual about that. And what our clients want to know is, well, what's so bad about feeling good? And it's a great question, because they will say, I'm just using this to relax, I'm just using this to unwind, I'm using this to feel better, I'm using this to have fun, I'm using this because it's the way my friends and I socialize. What's so bad about all of that? Well, there are a couple of things to keep in mind, particularly about drug reward. First of all, drug reward is abnormal. Drug reward happens even in healthy, otherwise satisfied animals. So drug reward isn't meeting any particular need that we have. It can reward us even when we have no need, nothing pushing us to do something different. So it meets no obvious physical need. But it can actually produce physical need. For example, alcohol is dehydrating, and so drinking a lot of alcohol can actually lead to thirst, which is a physical need, a need to replenish the fluids in my body. Also, drug reward is not diminished by quenching, which means that when I've done it, I kind of want to do it again, and I want to keep doing it until something sort of stops me. Now, early on, I will have some degree of control over that. It's like, oh, okay, that's enough. But over time, the fact that drug reward is not diminished by quenching does not mean that I might continue to use a substance or drink the alcohol or whatever, even though it's not meeting any particular need. Nor is drug reward enhanced by deprivation early on. That means that's my way of saying that let's say that I have not gotten buzzed on alcohol for a week, and I've come around to Saturday now. That buzz isn't going to feel better because I didn't do it all week, and it's just going to be there as a buzz. Now, later on, particularly if I'm beginning to experience some withdrawal or what have you, the pleasure can be enhanced by deprivation, because now I've produced a physical need that this drug can help or relieve. And so in that sense, I may experience more reward about that. Now, because the drug reward is abnormal, it sort of sits outside of the normal rewards that we experience in life. It causes abnormal neuroadaptation in the brain. And the brain will now start to change in some unusual ways. One of the ways that that happens is tolerance. So let's think about what happens with tolerance. And in this case, I'm talking specifically about tolerance to the euphoric effect of the substance. Actually, when we talk about tolerance in our field, in the alcohol and drug field, we tend to use the word tolerance specifically to talk about creating a tolerance to the euphoric effect of the drug. But we should keep in mind that there are a number of different tolerances, and they move and change at different rates. So, for example, where cocaine is concerned, I may develop a tolerance to the euphoric effect, the rush that the cocaine is giving me, but not develop an equal tolerance to its effect on my heart. So I may, in chasing the high, I may overdose the heart because the heart has not developed a tolerance as rapidly to the stimulating effects on heart rate as I have developed a tolerance to the euphoric effect. And so I may get cocaine-related or stimulant-related heart failure or this racing heart that can lead to heart failure. So go back to our $20 bill. And let's talk about reward and tolerance. If you'll recall, I said I was going to come back to this. If every time you went to a training, the first thing that happened was they distributed $20 bills, after a while, you would no longer view that particularly as rewarding. So an expected, anticipated reward becomes less rewarding to us than an unexpected reward. We develop a tolerance to it. And as a matter of fact, after a while, we become to view that as so normal, it wouldn't even be rewarding. It would just be a part of, oh, I've got to go to this training, and oh, yeah, they're going to give me a $20 bill. And if it didn't happen, I might feel some loss, but I'm not going to feel any particular excitement or enthusiasm about that $20 bill. So I will have sort of developed a tolerance to that reward. So we all experience tolerance, and drug tolerance is a normal, unavoidable process because of the nature of reward. When the reward becomes routine, we develop a tolerance to it. So increasing tolerance to pleasure, then, does not always increase to other effects, including the health problems. There are different kinds of tolerance. There's a tissue tolerance, and this relates to changes that have gone on in the brain where the brain actually makes itself less sensitive, the brain tissues, by changing the density of receptor sites that are in the brain, or by creating fewer of the chemicals that I might need to experience the drug pleasure or whatever it is. I will have a tissue tolerance, an altered neurochemical production, altered neurochemical activity, even altered genetic activity. And one of the things that we are coming to recognize is that environmental factors can actually change what genes are getting expressed out of our genome, so that because of the effects of the drug on the neurons and the glial cells that exist in our brains, the genetic expression within those cells may actually start to alter to create less sensitivity to the drug. So even altered genetic activity. And then, as I mentioned, another change that can happen are changes in receptor sites as a result of that alteration in genetic activity and specific changes in transporters. And these are structures in the brain that help to recycle the neurochemicals that we have. So I'm not going to do this particular example here, but you get a sense then that one of the neuroadaptations that is going on because of our high-risk alcohol and drug use is the development of tolerance. Now, a second one is going to be around memory and learning. And recall that when I was talking earlier about the euphoric reward, that I mentioned that one of the things that happens is I develop a memory of that experience that is very positive because my reward threshold is lowered and because everything in that environment seemed more rewarding to me, then my memory of that is going to be different. And what I'm going to be learning is that the drug creates that environment for me, and I'll want to return to it and spend more time there. But there are other things that are going on with this as well. So memory and learning are intertwined normal brain activities. And I keep referring to these as normal because one of the points that I want to make is that the alcohol and drugs are actually taking sort of our normal brain systems, and they are sort of hijacking and using them in a way that is abnormal. But they are happening because we already have these existing systems here in the brain. So our memory is gated through the hippocampus, this structure that you will see here flashing on and off. And the the effect that you get here is that our hippocampus pulls up memory from many different parts of the brain out of our motor cortex. If we're going to do some physical activity that we have learned, it will pull up our muscle memory, if you will, of how to do that. It will pull up emotional memory, and so on and so forth. So that's gated through the hippocampus, but that's not where all of it's stored. It's actually stored all over the brain. There are various memory functions that are mapped to different brain regions. And we have all of these different kinds of memory that are going on. We have declarative memory. So if I asked you to tell me the multiplication table, you could pull that up from memory and, you know, do your sevens, as my fifth grade teacher used to say, you know, or fourth grade teacher. So sort of math problems and so forth. We also have perceptual memory. If I ask you to describe the taste, texture, and so forth of apple pie, probably most of you could do that. That memory would carry with it a sense of the experience itself. Then we have motor skills, as I've already mentioned. This is our procedural memory. For instance, how do I go about changing a flat tire that I have on a vehicle? And knowing how to do that is not only knowing a process from declarative memory, but also the motor skills of how to actually do that. Then I have episodic or autobiographic memory. So when I have that flat tire, I can tell you where I was going, what the event was, what point that was in my life, and so forth. So I sort of have this autobiographic memory. And then I have what is called conditioned incentive memory. And these are emotional memories of pain or pleasure. So once again, our $20 bill here is giving us a conditioned incentive memory. If you had actually been in an audience where I had actually awarded someone that $20 bill, and if I were now to pull another $20 bill out of my shirt pocket, your memory of my previously having given away that $20 bill would now excite you about, ooh, is he getting ready to do it again? And that would create a motivation to sort of get ready and act in the same way that you were asked to act in that previous occasion. And of all of our memories, the emotional memories of pain and pleasure are the most powerful. So when we have a very powerful emotion, virtually everything around that event gets frozen into our memory. My example of this is to think about the terrorist attack on 9/11. When I ask this question across the nation, people can remember the weather on that day because across virtually the entire United States, at the time when people were learning about the attacks on the Pentagon and the Twin Towers in New York City, it was a clear, sunny, cloudless day virtually across the whole country, and people remember that. If I ask them what the weather was the day before that, no one can recall. That very powerful emotional memory freezes other elements into our memory all around it, even though they're sort of irrelevant to the memory itself. And I mention this because for many people, their first drug experience or their first use of alcohol is an emotional memory that is quite powerful for them. So it's a powerful memory. High-risk alcohol and drug choices impact all of these memories through the release of various neurotransmitters, dopamine, glutamate, serotonin, and others. So looking at this drink here, I can tell you what it is factually. I can tell you if I have drunk it, I can tell you what it tastes like and whether I thought it was really good or so-so or nasty. I can, if I've learned how to make this drink, I can tell you the process for making it and what you have to do. I can tell you when and where I have used that in my life, and I may also have emotional memory around it. Now, one of the important things to recall about the function of memory, the purpose of memory. The function of memory is to recall things from the past, but that's not the purpose of memory. The purpose of memory is not to recall the past. The purpose of memory is to predict the future. That is, by calling up what I know from the past, I try to predict what's going to happen in the future. And so, again, when I'm working with a group, I typically repeat this a couple of times. The purpose of memory is not to recall the past. The purpose of memory is to predict the future. And in doing that, the purpose of memory is not to recall the past. The purpose of memory is to, and the group can finish this, the purpose of memory is to predict the future. And the point is that you just did. If your mind was going, the purpose of memory is to predict the future, then that's just what you did. You predicted how we were going to finish that phrase. And so the purpose of memory is actually to predict what's going to happen next. So we use memory to try and fashion how we should do things and what we should do. So we all predict the future based on the memory of the past. If I have been using my the alcohol or the drugs for the purpose of getting high, to relax, to unwind, to have fun, to party, to whatever, and it has worked for me in doing that, then my prediction of the future is if I go back and do those same things all over again, then I'm going to get in the future the same thing that I've gotten in the past. And so this becomes a powerful motivation for me to keep on doing that. And even when the alcohol or drugs begin to give me problems, my memory of how well it worked in the past can make it harder for me to predict that the alcohol and drugs are going to give me problems in the future, because my powerful memories are that it gave me really good things in the past. And so when the problems happen, they seem to me unrelated to my alcohol or drug use. So I associate them with bad luck, or I didn't plan as well as I should have, or somebody did something that made it turn out differently this time. So I tend not to associate the alcohol and drugs with problems. So a crucial part of my recovering from an addiction oftentimes is retraining my memory to understand that the use of this substance is going to cause problems. So for example, I have a friend who's in recovery, and today when someone offers him a drink, he no longer calls up from the past the memory of all the good times he had with the drink. For him, he calls up the painful memories of how having one drink led to binge drinking and then ultimately to real problems in his life. So that one drink becomes for him, in his memory and his prediction of the future, a source of pain and problems. And that is a motivator for him to refuse that drink, to stay away from it and even to avoid situations where he might be offered a drink. So the purpose of memory and learning is sort of hijacked in the beginning, and a process of recovery is going to be retraining my memory and my learning into something different. So my memory is hijacked. Memory is intended to build a motivation for life-enhancing pain and pleasure experiences. And I mention pain in here because pain is intended to be a lesson. Pain is a way that we learn to avoid or not repeat something that we have done in the past, and so is an important part of our learning experience and builds motivation for us to shape our behavior differently in the future. But with the alcohol and drugs, my memory is now hijacked and is suggesting that if I continue to do what I've done in the past, make the high-risk alcohol and drug choices, I'm always going to get the positive outcomes that I did then. And this also can create a difference that happens in the brain here, and where we get what are called drug cues or triggers for craving happen because weak signals get paired in the brain with very strong drug signals. So let's suppose that we've got here a little neuron. This is our little neuron A here. And connected to it through this synapse over here is a neuron that picks up auditory sounds. And I hear a tapping sound. Now, that tapping sound is not a big deal. I just hear sort of a tapping, and I get this weak little response here in this neuron. And if that tapping sound is strong enough and the signal here is strong enough, it may set off a bit of a weak response over here. But suppose that tapping sound is me cutting cocaine on a mirror. In that case, the tapping sound is followed very soon after by this very strong signal from the cocaine that lights up this neuron very powerfully over here. So what happens is, in my memory, the tapping sound is now associated with the cocaine and the reinforcement that I get here. So after a while, I can take away the cocaine itself, and just the tapping sound is now going to create a weak signal here, but a very strong signal over here. So the tapping sound now has created a conditioned response in my brain based on memory of what used to happen when I heard that tapping sound, and that strong response over here can now create a feeling of craving or wanting for the drug, even though the drug itself may not be present, just the trigger. So my memory is hijacked, responding to minor cues when the brain senses an opportunity for the drug. So I have a friend who's a heavy marijuana user, and this picture that you see right here of the marijuana is for him a very powerful trigger of all of his pleasurable memories about cocaine use. And so when he sees this picture, he has a powerful emotional response to it. And that type of response revs up motivation to repeat the drug use regardless of the outcome. And this is important because this is not a part of our thinking brain. This is more part of our feeling brain. Our thinking happens more in the front part of our brain, in our frontal lobes up here, or the prefrontal cortex, as it is called, where I do more of my reasoning and, thinking things through. But deeper in the brain are these powerful emotional responses around motivation and so forth. So this memory and learning is also going to create another form of neuroadaptation, which is salience, or how important something is to me and how sensitive I am to its presence in the environment, or even the possibility of its presence. So our brain actually has a normal way of prioritizing stimuli. For instance, until I mention it, probably nobody is really noticing that your clothes are touching you. Now, your clothes are touching you. Your nerve endings are picking up that your clothes are touching you and is even sending signals to your brain that your clothes are touching you. But until I mentioned it, your brain was probably totally ignoring that stimulus. And the reason for that is we're so used to our clothing touching us that unless it's gotten uncomfortable for some reason, we don't pay any attention to it. Our brain has decided that it is a very low priority for us to pay attention to our clothing touching us. And so for all intents and purposes, as far as our brain is concerned, it doesn't exist. That stimuli, even though it's present, doesn't create any response in our brain. But if we choose to think about it, we can feel our clothing touching us. So the stimulus is always there. So when I become sensitized, though, to something that is happening, sensitization is a behavioral, physiological, or cellular response to a stimulus that is augmented or increased as a result of previous exposure to that stimulus. So I can develop a sensitized response to the presence of the drug or even the cues around the drug, the sights, sounds, smells, certain people, certain times of the day, and so forth. I develop a sensitized response to that time or place or person or experience or sensory input. And when that happens, it can set off the memories and even the desire to go back and get the substance. It reinforces the behavior. And this is a large role that dopamine is playing in our brain. Dopamine is produced in the ventral tegmental area, which is a very deep part of the midbrain that sits right on top of our spinal cord. But those dopamine cells send out axon or small threads to our emotional systems in the nucleus accumbens and also into our frontal cortex, where we think and identify things and pull up factual memory. So here is the ventral tegmental area down here, and here are the axons coming out from there that create this motivation to go and get something. And as I develop a sensitized response to that drug, so I've learned to value marijuana. And so now when I smell it, this part of my brain where my dopamine neurons are located are set off, and they send stimuli out into these different parts of my brain saying, "Ooh, wow, there's some marijuana around here somewhere. Maybe I can get some of it." And so they go looking for it. This can also alter, I mentioned earlier, altered gene expression. So what we have here is a picture, an actual electron microscope picture of a neuron. And we've come to understand in our society that our genes can affect our behavior, but we don't yet fully appreciate that our behavior actually can change the genetic expression in this neuron. So here's the body of the neuron itself, and it's got all these branches, these arms coming out from it, the dendrite here. And by changing the genetic expression that's going on in here, I can actually change the physical structure of this neuron that we're seeing here. And so the cocaine increases the density of these dendrites, which is a mark of this structural plasticity or this change. It's a process that expands communication among brain cells, and this is not an effect that we see in response to more normal stimuli, for instance, like food. So this is now a very powerful signal that is developed, a signaling system that is actually developed in my brain that makes the cocaine the cocaine signals a more powerful signal in my brain, something that we don't see with more normal reward. And in this illustration here, we also see that on this dendrite, here is the density of receptor sites that are out here, these little bumps on this stem on the dendrite out here. But with cocaine exposure or other drug exposure, the number of receptor sites can actually increase by a huge amount. There can be a flip side to this. This may create sensitized responding. On other neurons, I may have reductions of the receptor sites there, and that may create tolerance. That is, those neurons are less responsive to the effects of the cocaine or the marijuana or whatever it is. And so because of that, then on some cells, I'm developing tolerance to its euphoric effects, while at the same time I'm becoming more sensitized to its presence, the cues that tell me that it's available. So the brain measures the potential for pain and pleasure based on a memory, and opportunities for each of these provoke a dopamine spike, especially if we're wrong in our predictions. So, for example, one of the reasons that the $20 bill is more of a stimulus when I give it away in a group is because it was an unexpected stimulus. Most lectures at workshops do not begin with the presenter giving away a $20 bill. And so because of that, because it was not predicted that that was going to happen, it becomes a more powerful stimulus for us because there was no prediction, or there was a wrong prediction that a $20 bill was going to be given away. And that helps us learn what needs attention and what does not. So that $20 bill, if I were to even reach up toward my shirt pocket, if you were in an actual face-to-face group with me, if I were to actually reach up toward my shirt pocket at this point, you would have a sensitized response to that simple gesture based merely on my having given away a $20 bill earlier in the presentation. So nobody predicted.
Allan, I have a couple of questions or comments.
Okay, sure. Let's stop and do that.
Okay. Well, one is asking specifically what you were just going over. So the pleasure of use is more powerful than coding the pain until the brain is retrained?
Yes. Well, I say yes. Say that again. So the
pleasure of use is more powerful than coding the pain until retrained.
Yes, yes. And it's important when it's important to understand, especially when we're dealing in treatment settings. By the time people show up in treatment, many of them are, in fact, self-medicating pain. But early in use, if you go out and measure or ask people why they are using early in their use, many of them are not using to stop pain. They are using to increase pleasure. Now, of course, over time, the use starts to create painful experiences and can create depression, anxiety, and other negative emotions. And along the way, they also learn that they can shut down those negative emotions by the use. But early on, in particularly, why people are using is not to shut down the pain, but to enhance the pleasure. Does that make sense, I hope?
Yeah, and I think this next comment enforces that. It says, role of the reward pathways in terms of biochemical processes play an instrumental role. which is why people return to a habit despite adverse side effects.
Yes, that's correct.
Okay, I think that's it for now. Thanks.
Okay, all right. And by the way, do feel free to stop me, because my default is to kind of go on until someone does raise a question. So feel free to do that.
Thank you.
I should have said that up front. Yeah. Okay. So to sort of think about where we are here, because not many people that come to when I'm doing a face-to-face session here predict that there's going to be a $20 bill given away, that inaccurate prediction makes for a more powerful learning experience and made the reaching for the pocket and the $20 bill a reward cue. In other words, reaching for the pocket has now become a salient cue that there might be a reward, or at least the opportunity for a reward in the offing. And I use that simply to note how easily reward can modify our feelings, our beliefs, and our behaviors, because those happen at a sort of unconscious level that we're not even aware of in the beginning. And then we're like, ooh, maybe I can get a reward here. But that cognitive thinking of that comes later in the whole process. The other sort of more emotional responses are faster. And so drug cues take on a greater salience and create a sensitized response, the power to grab attention. So before, someone may have driven by in a truck that has on the back of it 420, which is, as I'm sure at least most of you know, is sort of code for marijuana use. Before, that truck may have driven by with the bumper sticker on it, and I may have thought nothing about that. But now when it drives by, because I use marijuana and because I have become sensitized to cues in the environment, that bumper sticker now grabs my attention, and I go, ooh, that's one of my people driving that truck. And so just simple things like that become reminders to me about my drug use. They gain the power to grab my attention, and they can also gain the power to motivate action, because now thinking about that, I might go, ooh, it'd be nice to have, you know, a bowl of marijuana right now. So all of these neural adaptations are going on, and they're part of this growing cycle that I have that is pushing more use and making it more likely that I'm going to continue. Now, as I continue to use, I'm going to begin to have negative experiences, and I'm going to begin to have problems. And because of that, I'm going to get some negative I'm going to get some pushback on my drug use. But I'm going to have learned that when I'm feeling stressed or down or bad, that the use can relieve that pain. And so now I've added to the positive reinforcement that I had up here, the negative reinforcement. So positive reinforcement we can think of as adding pleasure, whereas negative reinforcement we can think of as taking away pain. And so this negative reinforcement can now begin to become another motivator for my use. Part of this can happen because as I begin to develop a physical or a physiological dependence on the drug, I'll begin to have other types of rebound. So remember that we talked about a reward rebound before, but I will have other rebound effects. So if my use of a stimulant, for example, has been that it has given me a lot of confidence and a lot of energy, the rebound effect from that will be that maybe I'm less certain and I feel tired and it's hard for me to get myself motivated to do something. If the effect of alcohol was to depress my central nervous system, then the rebound effect may be that when the alcohol goes away, I feel jittery and irritable. If the marijuana effect was to get me really focused and relaxed, then the rebound effect may be that I become more anxious and it's harder for me to get focused. So I begin to have these rebound withdrawal effects. And what I learn is if I use a little more of substance, then I can ease off the rebound effect. So going back to our reward threshold being temporarily raised, we can think of all of these, let's think about this in terms of pleasure. All of these things here, friends, money, hobby, love, all of these things, family, and so forth, all of these are pools of life pleasure, and these are things that we normally use to relieve stress and enhance pleasure in our lives. We call on friends, we use our money to make us feel more secure or to purchase some pleasure. We take time away from things that we have to do to spend some time doing things that we want to do in our hobbies. We experience love in relationships, positive reinforcements at our jobs, love within our families, and so on and so forth. So we take a dip, if you would, in these pools of pleasure. When we add a drug reward in here to this, then what happens is this creates another much larger pool of pleasure. Remember, this is an abnormal pleasure, but it does so by taking away my ability to experience pleasure in these other arenas here. So all of my other pools of pleasure are now shrunken in order to feed this pool of pleasure. And so the brain's reward and motivational systems rebound to this higher reward threshold, and now I experience more malaise and fatigue, chronic irritability, emotional pain, depression. I'll have less motivation for those natural rewards, and I will have an increase in baseline anxiety. That is, it is easier now for me to be made anxious, irritated, or to feel down because of this rebound effect that I'm having. In a more severe form of this, I may develop a condition known as alexithymia, which is a difficulty to even know what I'm feeling. I just begin to feel numb much of the time. And this will create poor self-awareness. I don't know how I'm feeling. And it will also make it harder for me to empathize with how you're feeling, because if I don't know what I'm feeling, I sure as heck don't know what you're feeling. And so it can begin to affect relationships in that regard. Now, remember that when we were looking up here, things were more short-term. So this euphoric reward was short-term, the rebound effect was short-term, and then I would come back to baseline. Down here, I'm now going to develop what is called an allostatic, or an allostatic norm, or an allostatic state. And allostasis is actually a new normal, if you will. So I'm now developing a more chronic ongoing state, and this is because of changes in the neurochemistry and in the structures in the brain. So I will have higher levels of corticotropin releasing factor, and this is one of my stress chemicals. So I'm going to have more stress. I will have more norepinephrine, which will create a greater sense of stress. I will have less GABA. GABA is, as I mentioned earlier, GABA is actually the chemical, the major chemical in our brain that sort of slows us down, soothes the brain. So my brain, because I have less GABA, my brain now is going to be more sensitive to stress and anxiety, and I will have less ability to soothe myself when I am irritated or anxious or what have you. I will have less of neuropeptide Y, which also higher levels of neuropeptide Y are associated with less stress. So when this is depleted, I have more stress. And I will also have alterations in my natural opioid production. I will have more dynorphin, and dynorphin shuts down the dopamine system. And recall that dopamine is about motivating us to do things. So I will be less motivated to do things. And on the other hand, I will have less endorphin, and this loss of endorphin means that I'm going to experience more pain and less pleasure. So I'm going to have lower dopamine levels, less motivation, and lower glutamate production, which means that I will have be less alert. Remember that glutamate is our major natural stimulant. It helps me to get up into an awake, aware, focused state. And so these changes have been found across a variety of addictive substances, and it's one of the things that they share in common in their impacts on the human brain. And so because of these rebound effects from using the drugs, I can get into these states sort of chronically and become less motivated, more irritable, and less able to soothe myself, more anxious, and so forth. And this is an allostatic stress state. This is becoming the way in which I now normally function. So I've moved from a homeostatic state to an allostatic stress state. And this is where I'm now spending most of my life, is in this allostasis, rather than when we started over here in homeostasis. So what this means is that the inevitable stresses that life brings on us, if it's nothing more than having to pay the bills during the month or tend to the normal needs of child care, for instance, just the normal stressors that are a part of my life are now going to take on more power to be more stressful in my life. So we've talked about a reward threshold. We also have a stress threshold. So in a very similar diagram here, we all have these small stressors that don't really reach our stress threshold. These are things that could potentially stress us, but we sort of shrug them off. They're not that big a deal. We let it go. We move on. We have mild stressors, and then we have major stressors. And what happens during the acute high that I experience with alcohol or drugs, and this is early on as well as later too, is that my stress threshold is raised. Recall that my reward threshold was lowered, but now my stress threshold is raised, which means even these larger stressors, while I'm under the influence, seem less stressful to me. So this is, again, negative reinforcement. It is turning down the pain. It is turning down the pleasure in my life, so I don't feel it as much. But, of course, as we saw before, I have a rebound effect to this, which means that even the small stressors, when I'm no longer high over here, even the small stressors that I might have shrugged off or dealt with a minimum of effort in the past, now take on more power to become more stressful to me, so that my life is now filled with less pleasure and more stress. And over a while, this can become a chronic condition, an allostatic state. So the brain's overactive stress systems produces an allostatic stress state with those little stresses that we used to deal with, now becoming a big issue, a big deal in our lives. And this will make our life less rewarding. What shuts down stress is reward. What shuts down reward is stress. So if my brain is now sensitive, more sensitive to stress, I'm going to experience less reward. During this same time, if I try to quit, I can get something that is called craving incubation. That is, for a period of time, instead of the craving going away, it can actually increase for a number of weeks, and then it will start to taper off. So this is also related to a change in ERK signaling. ERK is a kinase that is produced in the, well, it's produced in different parts of the brain, but its role in the amygdala is, again, to sort of signal that there's something that I need to pay attention to here, and I get this increase in ERK signaling in the amygdala. And the amygdala is our fight or flight center. It is a seat of our emotional responses. So it can, my amygdala sort of gets on high alert. Also, something called a brain-derived neurotrophic factor in the bed nucleus striatum also is increased, which can create this craving incubation. And these increase for a period of time, for several weeks, and can make craving even stronger early on. The important thing for clients to understand in this is, one, they are not doing anything wrong, and two, this is a normal part of what their brain is going to do, and perhaps most important of all, this won't last. It will start to go away. There is a light at the end of the tunnel, because if they don't know that, they may become overwhelmed during this period by this craving incubation. It's a period that's at really high risk for relapse, because even though I'm not using, it may seem that the craving is getting stronger for this brief period of time, for several weeks. Fortunately, this does begin to taper off after a period of time, and the craving will actually drop and really begin to decrease. So let's go back to something that I said earlier, that our brain sort of takes in the world, that our brain is our window on the world. But what I'm dealing with now is an altered brain. So my brain has changed, and what this means is that my view of the world is going to change. The world is going to seem to me like a more stressful, less pleasurable place than it used to be. It's going to feel like I have the weight of the world on my shoulders at times, and that's going to be a feeling that is going to be more frequent because of these changes that have gone on in the brain. Now, it is often around this time that people will begin to seek treatment, or will become more willing to seek treatment, because now it seems like things are not going quite as well. Of course, another part of that is that all of this allostatic state that I'm experiencing down here with more stress makes it more likely that I will continue to use in order to now medicate this state that I've gotten myself into. So the high-risk choices have led me into this state, and now I'm viewing the continuation of the high-risk alcohol and drug use as a way to fix that state. And of course, that just makes all of this worse. It's a cycle that grows over time. This is complicated by the fact that at the same time, the high-risk alcohol and drugs have impaired my ability to do good decision-making. Decision-making is something that is done in the front part of my brain up here in the prefrontal cortex, the dorsal lateral prefrontal cortex and the ventromedial prefrontal cortex. And we do our decision-making as a result of an interaction between this part of our brain and the amygdala, which and striatum and hypothalamus, these structures that are up in here that I mentioned, the amygdala earlier. this is our emotional go get it, go do that system. Go do it. The amygdala, the hypothalamus, this part of the brain, all of this in here, is our impulsive system. And we need that at times. When a threat is coming at us, we need to be able to react very quickly to that. And we don't have time to think it through. We have to just react. If someone is swinging a ball bat at us, we can't take the time to say, what should I do here? We have to duck or block or do something to keep ourselves from being injured. And it's not a thought process. It is an instinctive process. That's happening back here in these deeper parts of the brain. That's impulsive. But out here in the prefrontal cortex is our more reflective system. And when we are going to make a decision about doing something, it is an interaction between this impulse and this reflective system that leads us to a decision. So let's think about, for instance, buying a new car. So maybe I go to a dealership and I see this great car. I mean, I love the lines on this ar. I think it looks really great. In my mind, I can see myself in this car blowing down the freeway with the radio on, and I'm thinking that I would love to be in this car, that I would love people to see me in this car. All of this is my amygdala in many ways going, ooh, I want it, go, 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 do that, get it. This other part of my brain is going, now hold on a minute, how much does this car cost? What's the resale value? What are the payments on this going to be? And can you really afford this? What kind of a safety record does this make or model of car have? So it's wanting me to think about other things. And before I buy the car, I'm going to feel, oh, I really want this, but I've got to make my decision based on other slower, colder factors. Now, what happens with high-risk choices is that this front part of the brain over here becomes more muted, and this more instinctive, impulsive part of the brain becomes more active. So I've got this impulsive, do it now part of the brain that gets stronger, while the let's slow down and think about it part of the brain becomes more blunted or more muted in its ability to halt my impulses. So with a history of high-risk choices, the amygdala has an exaggerated incentive response to external drug cues. The ventromedial prefrontal cortex and other brain regions related to internal emotional memories become blunted, so it becomes harder for me to remember the pain that this drug use has created for me in the past, and in combination, these changes will produce poor decision-making. So it becomes harder for me now to make decisions, especially based on long-term outcomes versus a decision based on immediate gratification. So if I've got to choose a long-term outcome that I want over an immediate reward, I begin defaulting toward the immediate reward more and more often. So
I have a question. I think that this is
okay.
a good time to ask it, since it's
okay.
to be appropriate for what you're talking about. They say, referring to craving incubation, is this process produced more quickly in adolescence and or with genetic predisposition?
It's a great question. In regard to adolescence, I don't think we know. I don't know that craving incubation has been studied in adolescence, and so I'm not aware of any research that has looked at that. so I don't know the answer to that question. What adolescents are dealing with, and to go to the second half of that question, genetics, adolescents taken as a group compared to adults are more impulsive. We know this. They have a reduced capacity already to rein in their impulses. And if you think about the development and maturation of the brain during the adolescent process, the maturation of the brain actually starts in the back of the brain and works its way toward the front, so that the frontal lobes are the last part of the brain to mature. What that means is that they will become more impulsive, that the impulsive part of the brain is maturing before the frontal lobes that are supposed to shut down the impulses when they can produce problems. And so adolescents are less likely to have impulse control, but some people just genetically have less impulse control than other people. Remember that I said way back at the beginning that we come sort of hardwired. Some people are more impulsive from the very beginning. Now, high-risk alcohol and drug use will make virtually everyone more impulsive, but some people have less impulse control from the very start. And so for those people, the impulses becoming stronger are going to happen more rapidly. I don't know if that answers the question, and I don't know how that specifically relates to craving incubation. Craving incubation is a specific phenomenon. Impulse control is my ability to shut down that craving. So adolescents may have less ability to shut down a craving if they experience it, and people with poorer impulse control because of their genetics may have less ability to shut down the craving. But that's not exactly the same thing as craving incubation. I hope that makes sense.
I have two people that are showing their hand raised, so it's usually by mistake. But I'm going to see if these people actually want to be unmuted to ask you a question. Just a moment.
Okay, so let's go ahead.
Francine, are you there? Do you want to ask a question? Francine?
Oh, no.
Okay.
Okay.
You again. Thanks. Okay, we'll try one other person.
Okay.
Okay, Terry, are you there? Do you want to ask a question? Terry Papin? I think that was clicked by mistake too. Okay, go on. Thank you.
All right, thank you. Okay, so when I'm talking about this impairment in decision making, it's not only their decisions around alcohol and drug choices, which become more impulsive and more difficult for them to control. They also begin doing poor decision-making in other arenas of their life, for instance, around legal consequences. So am I going to use this substance and put my custody of my children at risk or my job at risk? It becomes harder for me to make those decisions around legal consequences, around finances, and not just am I going to spend money on drugs, but here's a really cool thing that I saw at the store. Do I really need it? No, but I really want it. And so they may become more impulsive in their spending, which can lead to financial problems. They may even become more impulsive around things that they know will impact their health. And so you may recall, for those who are familiar with the DSM criteria, one of the things that can create problems is that people will continue to use despite health consequences that they may have. So this decision-making, this impairment in decision-making that happens can begin to impact various areas of their lives. And these changes in the brain will create less impulse control, and this impulsivity is acting suddenly in an unplanned manner to satisfy a desire. So people become more impulsive, and the changes that we just looked at also make it harder to control drug-cued impulses. It lowers the threshold yet again for signals to create a drug-related impulse. So now just the sound of some tapping that's going on can create craving for me and make it harder for me to control that. I may also become more obsessive in my thinking about the drug because the part of impulse control is being able to shut down obsessive thoughts. So probably all of us have had the experience at one time or another of getting a song stuck in our head, and it just sort of cycles around, and it's like, oh, I really got to quit singing that song in my head here. That's sort of obsessive thinking. But I can get hooked into this obsessive thinking on drugs, and it becomes harder for it to shut down. And that will create more impulsive drug behaviors because this obsessive thinking begins to feel like if I just take the drug, then I can quit thinking about it here. This craving will go away. This thinking about it will go away. And all of these things sort of added together can create loss of control. And loss of control is when I have progressed from impulsive drug use to compulsive drug use. As a matter of fact, one of the leading neuroscientists in the field, George Koob, actually characterizes the development of addiction as the movement from impulsive drug use to compulsive drug use. That's his definition in some ways, or sort of shorthand of addiction. So this impulsive action then turns into compulsive action, and compulsion is acting despite the desire not to take the action. So with an impulsive activity, I wanted it and I acted on it. In the compulsive, I don't want it, but I feel compelled to act on it anyway. And acting on compulsion is generally followed by feelings of shame, feelings of regret or guilt, and those are stressors that we may actually try and shut down by yet more use. And so this loss of control itself can become a cycle unto itself of I use, I feel ashamed that I'm using, and in order to make that shame feel less painful to me, the shame, the guilt, or what have you, I use some more to feel better. Now, in talking about these changes that go on in the brain, these are changes that come about as a result of the high-risk alcohol or drug use. It's really important that we not leave clients feeling like, oh, I've messed up my brain and I'm doomed for the rest of my life. Because if I feel like there is no hope for me, then I have less motivation or no motivation at all to change the alcohol or drug use. So as it turns out, we actually can help to reset our brain. Now, there are some changes that are not going to get totally undone. So the compulsion to use can go away, but my brain, the sensitization that has gone on in my brain is such that if I start to use again at some point in the future, my brain is going to rapidly become sensitized to that drug, and all of those processes that are sitting there around that sensitization are going to snap back into place, and I'm going to be back into this impulsive to compulsive use to loss of control and so forth anyway. So one of the most crucial ways for us to help to reset the brain is to quit making the high-risk choices with the alcohol or drug use. I've got to just quit. And this can be very difficult because my brain, you will recall, is pushing these feelings that create the thoughts of, oh, I really want to use. I really feel like I need to do this. And so Carlo Di Clemente, many of you are probably familiar with that name. He is one of the co-developers of the trans-theoretical model in the stages of change. Carlo Di Clemente is using a term these days that I really like a lot when he talks about treatment and recovery. He's using a term called scaffolding. And one of the powerful things that goes on in scaffolding is you can think of it as sort of building a scaffold around a building that you're trying to repair. So what goes on in treatment, learning new skills, becoming more self-aware, changing one's environment, learning how to get support for the changes that we're trying to make, all of those types of things you can think of as sort of scaffolding that's built around the person, the brain, and the life that they're trying to repair and change. And so the scaffolding that goes on can be helpful for helping people to quit. There are some other things that we can do that can actually contribute to brain health. So treatment, this back and forth that goes on either in face-to-face therapy or in group meetings or what have you, as people learn skills, they learn, they think through ways to cope with situations, they learn what does and does not work, and so forth. This back and forth that can go on in treatment can actually begin to retrain the brain, and over time, if I retrain the brain enough, I can begin to undo some of those changes that were there. I can, and that in turn can lead to my coming to view the world as a more hopeful, less stressful place where I can live and act more productively in that world. In addition to that, Dr. John Rady, who is a psychiatrist at the Harvard Medical School, wrote a book about the brain, and in it he mentioned some things that we can do for overall brain health. These are things that anyone can do, but they can be particularly important if we are trying to enhance the healthy functioning of the brain. So what you see here on the screen before you are examples of both physical and mental exercise. So using our brains to solve puzzles, to think new thoughts, to read new books, to have new experiences. All of those are brain exercises, as it were. And in addition to that, just doing physical activity, it increases blood supply to the brain and helps the brain achieve certain rhythms that can be very helpful for us. So physical and mental exercise is one of the things that Dr. Rady has noted can contribute to brain health. A second thing that he has noted is good nutrition. The foods that we eat contain the raw materials for good brain health, the organic brain, but also the neurochemicals and the proteins that the brain uses to create the neurotransmitters, the receptors, and so forth that we need for a healthy brain. So staying well hydrated as well as eating a balanced diet, good nutrition, all of these contribute to brain health. Getting a good night's sleep, and this is one that is often, we often hear the exercise and we hear the nutrition. Neuroscientists oftentimes call this the third leg of the stool that a healthy brain rests upon, is getting the proper amount of sleep. During periods of sleep, our brain does a number of things, not only releasing hormones that help to build muscles in the body and so forth, but also resolving stress. Probably a lot of us have had the experience of having a really bad day, but after a night of sleep, we wake up the next day. Nothing has particularly changed with the situation, but we feel more prepared to deal with the stressor. So getting an adequate amount of sleep also contributes to overall brain health. Spirituality, religious practice, spiritual practices, prayer and meditation, all of these have been found to be associated with a more balanced and a healthier brain. So from this, we often derive a sense of meaning and an experience of hope in our lives. And having meaning and hope not only is a powerful psychological experience, it actually is a good experience for our brain. It helps to balance the physical brain. And finally, you won't know what this is. These are actually some pictures that are drawn up from my own life. John Rady suggests that we need to be pursuing positive passions in our own lives. And so these are some of my family. This is my daughter and her husband. These are my other daughters when they were much younger. These are some of my grandkids. I like to travel and so on and so forth. So these are just things that I feel passionate about and enhance the quality of my own life. So pursuing positive passions, and these are very individual, of course. For some of us, it's our work that is a positive passion. For some of us, it is our families. For others of us, it may be some particular hobby that we have. But whatever it is, pursuing these positive passions. And by the way, doing things that are altruistic, things that help other people, have been found to be very positive for brain health as well. And so giving people opportunities for service to others can be a way of helping to reset the brain. So all of these things then are just ways that we can help to heal the machinery of the mind, particularly if it has been unbalanced and unsettled and altered by high-risk alcohol or drug choices. Okay, so excuse me, Chris, that pretty much concludes what I had to say here. I'm welcome to, I'm open to questions or whatnot that other people may have.
Sure, and I do have a couple. For everybody else, I understand that we have run a little long, so if you need to get out of this, that's fine. You'll still get credit for attending the full webinar. But if you'd like to listen to the answers for a couple other questions, you're certainly free to just stay on. This will also be in the recorded webinar, so you could pick it up that way too. Okay, so we have three here. First, and they're sort of on the same topic.
All right.
How long would residual effects of long-term substance abuse last once a person has stopped using? And are the changes mentioned permanent in any way?
Okay. Those are great questions, and they're difficult to answer because the answer can vary based on the particular substance that was used, the frequency with which it was used, the potency at which it was used, and also the sort of where the person started from with their own hardwiring from the very beginning. So it's not easy to give, a straightforward answer to that. Let me say that many of these things are reversible. once a person has reached an addiction, which has to do with the sensitization and the impaired decision-making and those types of things, well, let me back up. The sensitization can last for a long, long time, maybe even for the rest of a person's life. And so they may continue to be sensitized to those things that are in the environment. Just as an example, I was coming out of a theater. This was several years ago, but I was coming out of a theater that a group of us had been to. I attended a show at this theater, and we were just standing on the parking lot. And there was a woman there in the group. She just all of a sudden said, "Oh my gosh," she said, "I haven't had a cigarette in 13 years, but somebody just walked by smoking a cigarette, and I just wanted one so badly." So that sensitization can last for a long, long time. Now, a person's ability to control that impulse that that sensitization creates can increase with abstinence. So they become, it's not that, they become less likely to relapse back into use, but the sensitization can become fairly permanent, for at least for some people. For others, the sensitization seems to lose its power. It can be different. For instance, some of the changes, think about something like methamphetamine. Methamphetamine is a very destructive drug. It actually damages certain microscopic structures that are in the brain, the transporters, for instance, on neurons. And that damage takes longer to heal up than if a person was using cocaine, which acts differently in those same systems but doesn't damage them. And so, it's just hard to say. If a person was more impulsive from the very beginning, they can improve, but they have sort of a hardwiring that's not going to get better than it was from when they started. So I hope that makes sense, and I'm sorry that it's vague, but that's just because it's very individual.
Okay, and you just answered one other question somebody had. And
okay.
then this is the last one.
Okay.
Does a certain duration or frequency of use create long-term impaired decision-making or permanent brain damage?
Wow. And again, as you say, these are sort of related questions, and the answer is going to be really similar, which is, again, it is going to depend upon the individual and sort of how good was their decision-making, in the beginning. One of the things that may happen, if you've got people who are starting their alcohol and drug use, particularly in early to mid-adolescence, they have less impulse control, and that maturation of the brain may be slowed down because of their alcohol and drug use, and so they may continue to be more impulsive for a period of time than someone who, say, really started their, let's say they started high-risk drinking when they were, 20 years old and a college student. And so, at 19 or 20, they may have had more of that maturation process take place than someone who was, say, 14 or 15 years old. And so, again, where a person, how good a person's decision-making was from the beginning can play some role in that. And then, once again, what substances they're using and what potency they're using at and what frequency they're doing it with. All of those will play a role in how fast it happens and how fast people recover from it. Okay? Are we good? Hello? I seem to have lost you. So,
I'm
not sure.
Sorry. Yeah, I was just on hold. Didn't realize.
Oh, okay. Sorry.
I thank you for just spending all that extra time to detail the answers to all these various questions.
Sure.
And I think that will conclude the webinar. The attendees will receive the PDF of your presentation, and we ask everybody to complete the evaluation that we'll be sending along with those. So thank you, Allan, and thank you, everybody, for attending.
Appreciate it, and thank you for being here. And I hope it was helpful. You folks have a good afternoon and good evening.
Yes, thanks, Allan. Okay, at this time I'm going to close this webinar. It is being recorded and will be available on our website for viewing on demand. Thank you all very much. Goodbye.